All right, so let's get started. We're looking at the morning review worksheet. Okay, so we have given to us f prime. The derivative of a function is shown with f of 10 is equal to 5. We have table of values, g, g prime, and g double prime at various order pairs. And part A says find f of 4. Okay, so if we want to find f of 4, we have to involve the antiderivative in order to get from f prime to f of x, but it's asking for a specific position. So we have to involve the final position equals initial plus displacement. And the reason why we need to do that is because we don't have a defined formula for f of x. Right? We have to kind of build it from our starting point and from our f prime graph. Okay. Okay, so we have to rely on this formula in order to find that f of 4. So we're looking for f of 4. And we need to start at f of a. We need to have a starting point, and that starting point is going to be whatever is given. Okay, so this is our given starting point. So we start at f of 10 plus, and we're going to follow the rule, right? The rule says that we're always going to start at A and we end up at B. Okay. So I'm going to start at 10 and end up at 4. Even though we're going backwards, we need to make sure that we initially follow whatever the rule says. And if you want to make an adjustment later on, you can do that at the next step. Okay. But if you do it too soon, if you try to adjust the bounds at this stage, you may forget that there's a sign change. So I would encourage that just follow the rule, and then after you have the rule down, then you can decide if there's any adjustments you want to make. All right, so I followed the rule and I realized, wait, this is a little bit out of place. I would rather read from 4 to 10 than from 10 to 4. So now I'm going to take the time and effort to change the bounds. And as I change the bounds, I need to make a slight adjustment to balance that out. So I'll change the sign in front.
So Mr. Yang,
Mm-hmm.
Why did you say we put the 10 on the bottom again?
The reason why is because we have to follow whatever the rule says, right? And the rule says I need to go from A to B, right? And so these numbers have to match.
All right.
Initially.
B is the one we're trying to find.
That's right. B is the one we're trying to find. Right. Okay. So from 4 to 10, f prime, that means we have to involve areas of these triangles, right? And make sure that we're only concerned about the region between the graph and the x-axis. Hi. Yeah, and I have a worksheet there. I'll put this up. Okay. So I'm going to shade in the region here. So we're only concerned about between the graph and the x-axis. So I see some students, they shade in other regions. That's not part of the problem. So even though there's a triangle here, we don't shade this region, right? Because this does not incorporate between the graph and the x-axis. So only what's between the graph and the x-axis. Now, all these triangles, once we find an area of one, we can kind of figure out the others because they're all kind of symmetrical. So let's start with this one here. Area is 1/2 base times height. Okay. So base is 2, height is 4. So that's going to give me -4. And if this is -4, then that means all of these are going to be that area as well. So I'm going to just go ahead and fill those in. But these are above the x-axis, so I'll fill these in with a +4. And these are negative here. Okay, so f of 4 equals f of 10 is 5 minus parentheses. Now I'm going to add up all these values up. So from 4 to 10, we're looking at all these values here. So 4 minus 4 minus 4 minus 4. Let's see. I'm sorry, we don't have this last one here. So it's just going to be 4 minus 4 minus 4. Right, these cancel out here. I have 2 negatives. So 5 minus -4, that's equal to 9. Okay, next up. We want to find f prime of 7. So this is the f prime graph. So we can just simply rely on that, right? So f prime of 7 is just going to be this order pair here. Now this is a graph that has a slope. If we count, we see that this is a slope of -2. So we can just go down 2 over 1, down 2 over 1. So this must be f prime of 7 being -2. Just an order pair. All right, any questions so far? Okay, next part, we want to find f double prime of 7. So f double prime of 7 is not going to be a point on the graph, but the slope of the f prime graph at this point. Now this is going to be a straight line here. And we talked about how the slope was -2. So if I just pick any point on this line segment, I'm going to see it's just going to line up nicely with the slope. So
What would we do if it wasn't a straight line?
oh, it would have to be something that you can find easily. You know, if it wasn't a straight line, the only thing that that I would ask you, if it was like a semicircle, and if I asked you for the slope at that point, then you would say slope 0. But if it's a diagram like this, it'll be a geometric shape where you can find the slope. All right, part B. On what interval between -4 and 12 is the graph of f both increasing and concave up? So we're looking at the f prime graph. So we want to know when the graph is both increasing concave up. So our derivative graph, we know that we can think of our derivative graph and label accordingly. Above the x-axis is going to represent positive slope. Below the x-axis is negative slope. On the x-axis is slope equals 0. So gather information about the slope on my slope sign line. I'm concerned, I want to pick off the critical points that lie on the x-axis, so x-intercepts, so -2, 2, 6, and 10. Right? And then we just gather whether the region is above or below the x-axis in those intervals. So from -4 to -2 corresponds with negative because it's below the x-axis, negative slope. And then positive slope because these are all in the positive in the above the x-axis. From 2 to 6, still above the x-axis. From 6 to 10, below the x-axis. And then from 10 to 12, below the x-axis. Okay, moving on to F double prime, we also want to gather information about concavity. So I'll create a second sign line, but I want to line it up so I can see everything clearly. But now I want to pick out the points of inflection because points of inflection will be the critical points for my F double prime sign line. So now I'm going to pick off the peaks and valleys of the graph. So these, any place where there's a relative max, relative min are going to be the points of inflection of the original graph. So I have 0, 2, 4, 8, and 10. Oops, not 2. Yeah, 2. Okay. And then wherever we see positive slope, that's going to correspond with concave up, negative slope, concave down, positive slope, concave up. Okay, so it's going to keep alternating, starting with concave up. Okay. We want to find intervals where our graph is both increasing, so wherever there's an up arrow, and wherever it's concave up. So I want to see, do we have any intervals where both properties are showing at the same time? So if we look here, looks like between -2 and 0, we're able to get both of these to occur. So I'm going to highlight those intervals there, -2 to 0. And then also from 2 to 4, right? 2 to 4, also increasing and concave up. All right, any questions there? Okay, part C. Let j of x equal to 4x squared times g prime of 2x. Find the equation of the tangent line of j of x at x equals -1. So we want to find the equation of tangent lines, so we need to find order pair and we need to find slope. Let's find order pair. Let's see. So we need to find order pair. We need to find slope. Order pair, we know x is -1, so we can start there. And then slope, we need to find that value. Okay, so let's start with order pair. Order pair, we can find that just by relying on the original function presented to us. Okay, so just enter -1 for all the x's. So this ends up j of -1, 4 times -1 squared, that's just 1, times g prime of -2. So g prime of -2, we go to our table, which is -1. Okay, so there's our y value, j of -1 equals -4. There's our point.
Where did you put -2?
Right, so I just entered the -1 in for the x.
Okay.
Mm-hmm. All right, so now we've gathered the order pair. We need to find the slope. To find the slope, we have to find the derivative first. We need to find j prime. But to find j prime, we have to see what methods are involved here, what procedures are involved. And if I want to find j prime, look at how this is set up. These are two distinct terms, so I got to go through product rule, right? And then this g prime of 2x, there's a little bit of chain rule that's involved there as well. Okay, so let me rewrite the j of x function here. Okay, let me label the parts here. There's my f, this is my g. I'm just going to go through with the product rule. F prime g plus fg prime. Okay, so f prime is the derivative of this 4x squared, which is just going to be 8x. G function, no changes. We're just going to copy that down. Back to f, and then g prime. So what's g prime going to be? Yeah, the chain rule. Okay, so let me.
G of prime of 2x times 2.
Close. Let's see here. We got to do chain rule. So we need to find the derivative of the outside portion. My outside portion is just the g prime. And then my inside portion is the 2x.
Oh, so it's g prime prime.
That's right. Yeah, so once I've identified the outside and inside function, I'm going to take turns with each of their derivatives. Right, so like what you said, g prime becomes g double prime. Right. We fill the parentheses with the original So now that we've taken care of the outside, we're ready to move to the inside. So 2x's derivative is what? Times 2. All right, so there's our full derivative. Now we can worry about finding g prime of -1 so that we can get to the slope. J prime of -1. So replace every x I see with -1. We're going to go to our table of values to help find these missing values that we need to insert. So g prime of -2, that's going to be -1, and g double prime of -2, it's going to be +4. So I have 8 plus 32, which is 40. So there's my slope. My slope is 40. Now I can do point slope form. All right, questions there for part C? All right, part D, we have a limit problem. What's the first thing we do with a limit problem if it's approaching a real number? It's the first step.
Just plug it in to see.
Yeah, let's just plug in. Let's just see where we're at, right? We need to gather some information. We don't know if it's a real number. We don't know if there's a hole, if there's an asymptote. We just don't know, right? So we're going to find out. Right, so replace every x we see with 2. So e to the g prime of 2, g prime of 2 is just going to be -5. So I have e to the -5 minus 1 over e to the 5th. And then g of 4, I look at my table, I get 4 minus 4. So what does this lead us to? What is that result? Yeah, 0 over 0. And this is very telling, right? We know that there's a hole in the graph. A limit exists. So what can we do to handle this type of problem?
The Hopitals?
Yeah, L'Hopital's rule, right? So this is not something that we can factor. There's nothing that we can cancel out. So we need to rely on L'Hopital's rule. So L'Hopital's rule says take the derivative of the numerator, separately take the derivative of the denominator, and then once you create a different version of the expression, then reevaluate, and that should lead us to a real number. Okay. So we need to find the derivative of each of these terms. Now, as a reminder, the rule for e to the u is e to the u times u prime. Okay. So if we follow that rule there, that means e to the g prime becomes e to the g prime times what? What's derivative of g prime? G double prime, right? 1 over e to the 5th. This looks messy, but that's just a constant, right? So that constant is just going to drop out to be 0. Okay. Next up, we need to find the derivative of g of 2x. This is a little bit of a chain rule. So outside's derivative times inside's derivative. So we have first up, it's g prime of 2x times 2. And then the 4 goes away to 0 as well. So now that we have created a derivative versions of numerator and denominator, now we're going to try that 2 again. Before it gave us 0 over 0, but hopefully we can get a better result this time. So replace 2 in for all the x's. Okay, we go to our table of values and do a little bit of cleanup. I'll push that e back down to the denominator. Okay, any of these variations are fine. Okay, questions?
So when you did that, did you just throw the -4 and the -1 over e away?
Oh, the negative, I just moved it up to the top, but it doesn't matter. You can put the negative anywhere.
No, I'm talking about the -4 that we had in the beginning.
Oh, -4. Yeah, that -4 went away because we found the derivative.
Oh, so we don't need -4 and we don't need -1 over e.
Right, because when we do L'Hopital's rule, we're finding the derivative of every term.
Okay.
So the constants will just drop to 0, yeah. Okay. All right, second page. Is there a time on the closed interval such that g double prime of c, sorry, g triple prime of c is equal to 2/5? So here we're trying to find a specific third derivative value, and we're trying to guarantee basically a slope of the second derivative. So when we see this, and that should trigger a recognition of the need for mean value theorem, right? Mean value theorem allows us to guarantee a specific slope value, even though it is all the way down at this third derivative. So let's think about what mean value theorem looks like, and then we can adapt it for this specific problem. Okay, so we know mean value theorem has this original look, right? If you look on your formula sheet, so if I can figure out that there's a slope between the endpoints of a certain value, then I know that somewhere along this graph, there's going to be an exact steepness that also matches the slope that we found here. But now we're trying to guarantee a g triple prime. So we can look at the second derivative, right? If we can figure out the slope of the second derivative graph to be a certain value, then we can guarantee that the slope of that second derivative value of that second derivative function must have that specific number as well. So we're just going to adapt it, right? We know that this function is always going to be sitting one level higher than what we're trying to guarantee. So. So our A and B value. And we're just going to insert -4 and 6 all in for A and B and see if we can see if the slope between the endpoints gives us 2/5. If it does, then we know the slope of my second derivative graph must also have a steepness of 2/5. Okay, we go to our table of values above, right? G triple double prime. And we do get 2/5. So we can say, by mean value theorem, since G double prime is continuous and differentiable, just copying whatever the rule says on that formula sheet there. Okay, there exists a value where G triple prime of C is equal to 2/5. So just as a quick visual example or demonstration here. All right, whatever the second derivative graph looks like, okay, we found that the slope between two points on the G double prime graph is 2/5. So therefore, there must be a place on the G, there must be a slope on this derivative graph, sorry, on this G double prime graph that also matches that exact slope. So because the slope between these two endpoints is 2/5, there must be an instantaneous slope that's 2/5. So that's what we're able to guarantee with mean value theorem. Okay, part F. Let K be the function defined by K of X. Find K prime of 3. So we need to find the derivative. Now, if you look, this is not product rule, right? This is a function within a function. We got to go through chain rule here. So we need to identify all the different layers involved here. There's an outside portion of that G prime. There's the inside portion, whatever's inside that bracket, F prime parentheses minus 1. And finally, the innermost portion is within those inner set of parentheses, which is 2x. Okay, so we need to take the time to find each of the separate derivatives to produce the full K prime. Okay, so first things first, what's G prime's derivative? Just G double prime, right? Copy whatever's inside. Next up, we're looking for F prime minus 1's derivative, and that derivative is F double prime, and the -1 goes away to 0. And then we keep whatever's inside of that. And finally, the innermost portion's derivative, 2x becomes times 2. So that completes our calculus portion. The rest is just plugging in and trying to get that down to a number. So F prime of 6 double prime of 6 times 2. Okay. F prime of 6 is 0. 0 minus 1 is -1. Okay. Okay, so G prime of, oops, sorry, this is G double prime of -1, we go to our table. G double prime of -1 is just going to be -1. Sorry about that, got dropped for a moment there. So K prime of 3 equals -1. F double prime of 6. So F double prime, this is F prime, so F double prime is just going to be the slope of F prime. And so we talked about how the slope of this line segment is -2. So K prime of 3 is just 4. Part G, find the maximum value. So if we're trying to find the max or minimum, yes.
How did you define F double prime?
So this is F prime, right? So F double prime, if F prime of 6 is just that point, then F double prime must be the slope of this line segment. So if I just pick any point on this graph and I figure out the slope, my slope is going to be -2.
Okay.
Right, rise over bond, yeah. Okay. Are we good with part F? Okay, part G, find the maximum value. Anytime you're looking for a max or min value, you're going to be understanding that we have to apply extreme value theorem. So extreme value theorem says test endpoints. So in this case, endpoints are always provided for you. We need to find f of -4, and we need to find f of 12. And we also need to test critical points. But since we're only looking for maximum value, we only need to test relative max. There's no need to test relative min, because relative min has no chance of being the maximum of the graph. So we'll test our critical points. In this case, though, just a relative max. And if we go back to the previous part, we know we can look at our slope sign line and realize that there's only one relative max, right? Relative max is at 6. So that's the only point we need to test. Right? Don't worry about, there's nothing from the second derivative sign line that we care about, just f prime sign line, and we look at that sign line to help us out, so 6. Okay, so 3 points to test, f of -4 first, and just like how we found f of 4 from the original, from part A, we got to go through this final equals initial plus displacement. Okay, so I'll start at -4. Again, we have to involve f of 10 because that's what's given to us. So we have to start with whatever point is provided. Just like before, we have to copy the rule and then make adjustments if necessary. So now I'm going to change the bounds from 4 to 10 so I can read my graph in a straightforward way. And I just total all the region that I see from 4 to 10. Oh. Sorry, -4 to 10. Sorry, -4 to 10. So a lot more regions to find here. So -4 plus 8 plus 8 minus 8. That cancels out, so it's just 4, right? Next up, f of 6. Same rule. Start at f of 10 and go from there. And I still, yeah, I need to change the order of the bounds. From 6 to 10, it's only going to total to be -8. So 5 plus 8 is 13. And finally, f of 12. No need to change the bounds here. It's already in the order that we prefer. Okay, so we want to find the absolute maximum. We only have 3 candidates, and we see 13 is going to be the largest value, so we just say absolute by EVT. The absolute max is 13 on the interval from -4 to 12.
Sure.
Mm-hmm.
Why do you use 10? F of 10.
Oh, as a starting point, as for f of a, because that is the point that's given to us. So we have to start with whatever is provided for us in the problem.
Oh, okay.
Because there's no other points provided for us. So
Yeah, I
that's.
thought you were supposed to use -4 to 12.
Oh, we are, yeah. But because I'm using my final equals initial plus displacement, I got to have an f of a to build my order pair, right? So f of a is going to be whatever is given, and from there we can figure out what the progress is from that point. Okay. Part H. Evaluate. So this is pretty messy, right? And whenever you see a messy integral problem, we don't do chain rule, right? Chain rule is for derivatives. The chain rule version for integrals is called U substitution. So with U substitution, we're going to be able to get this hopefully down to something that we can actually recognize in terms of a rule that we can apply. So let me rewrite this expression here. And our first goal is to figure out what is the U value that we could target that will hopefully allow this messiness to go away. So some students have said, well, what if I choose the 2x? Well, that 2x is not going to be enough because this is like the messier your expression is, the larger you need your U value to be. So my u value is going to be more than that 2x. It's going to be this entire g prime of 2x. So everything inside this bracket here. And when we go through u substitution, we want to target our u value that we identified, and also we want to replace dx. And the hope is that after you go through that process, this will clean up into something that we can recognize in terms of an integral rule that we can use. So we'll let our u value be g prime of 2x. And to find the derivative, we have to do a little bit of chain rule here. So g prime becomes g double prime, that's the outer portion, multiplied by the inside portion, so times 2. Solve for dx, and we get du over 2 g double prime of 2x. And we make our substitutions. And we see a very clean, we see some cleanup that allows us to work out, right? So the g double prime 2x goes away nicely. A 2 gets pulled in front, but that 2 is in the denominator, right? So that 2 gets pulled out as 1/2. Okay. We can just apply a nice clean power rule from here. So 1/3, we add 1 to the exponent, right? We go through power rule, we add 1, so plus 3 over 3. And that becomes 4/3, right? Flip that 4/3, that becomes 3/4. We have our antiderivative. We got to involve the bounds, but I think maybe the cleaner thing is just get everything in terms of x, and then we can use the original bounds. So 3 over 8. Bring everything back in terms of x, and then I can now rely on my original bounds between -1 and 3. Upper bound first. Minus the lower bound. Make our substitutions. G prime of 6 and G prime of -2 we can pull directly from our table. They both end up being 1, or 1 and -1 rather. Okay, so if we get a messy answer, I think this ends up being 0, but if you get a messy answer, just leave it. There's no need to do anything past this point. A messy, unsimplified answer is perfectly fine. Same thing on the AP exam. As long as you get a numeric equivalent to a simplified answer, just go ahead and stop. There's no need to do anything more. Okay, questions here? Okay, part I, find the average value. So average value, we have average value theorem, right? So average value theorem looks like this. On your formula sheet. But I want to find the average value of f prime. So I'm just I need to adapt this average value for my problem. So if I want to find average value of f prime, still 1 over b minus a, but I now need to total the region for my f prime graph. Okay, so I'm going to use this adapted version of average value theorem. Replace A and B with -2 and 8. Okay. We total the region between -2 and 8. We get, that's going to total to be 12. So that just reduces to be 6/5. Okay, part J says find the average rate of change. So average rate of change just means find the slope, right? So all I need to do is to find the slope between two endpoints. So if I do change in f prime over change in x, I end up with the average rate of change. So basically just the slope of my f prime. So I have order pairs. F prime of 1 is 2, f prime of 8 is -4. That just comes directly from my graph. And I just do change in y over change in x. Okay, last part here. Says let p of x be the definite integral from -2 to 3x. Find the values of p of 1 and p prime. Well, I think p of 1 is easier. We'll start there. P of 1, we're just going to follow the rule. So take the integral from -2 to whatever my upper bound is going to be. So if I enter 1 in for x, I get 3 times 1, which is 3. So from -2 to 3, I'm just going to rely on my graph, right? Just total the values I see there, 4 plus 4. Now, that region from 2 to 3, that's going to be a smaller triangle. So if you find 1/2 base times height there, it's going to be 1/2 1 times 2. So that area is just going to be 1 there. So 4 plus 4 plus 1 gives us 9. The second part says find p prime of 1. So p prime of 1 means find the derivative of p of x. But if I want to find a derivative, I have to do a little bit more, there's a little bit more going on because that 3x, we got to go through second theorem. So second theorem, yes.
Can you go over how you got 4 plus 4 plus 1 again?
Yeah, so we find the region on the f prime graph between -2 and 3. So between -2 and 3, we just total these 3 regions here. So 4 plus 4 plus 1.
Oh, okay.
And this is a smaller triangle here, so it's a different, my dimensions are a little bit smaller here. Okay. For p prime, I need to find the derivative of this expression. And anytime I'm pairing a derivative and integral next to each other, I need to apply second theorem. So second theorem says these two operations are going to cancel out. My upper bound is going to get inserted into the function. So that's what it shows here, f of p of x, times the upper bound's derivative. So we're just following what the rule says here. So upper bound gets inserted in for t. So that's f prime of 3x multiplied by the upper bound's derivative. So times 3. So p prime is just this cleaned up version, which is f prime of 3x times 3. And once you have that cleaned up version of p prime, then replace all your x's with 1, and then use the graph to find your ordered pair, and then 2 times 3 is 6. All right, any last questions?
Did you just, for p prime of 1, did you just take the derivative of 3x?
That's right.
Okay.
Yeah. And that's what, because the rule says that, so I'm just following whatever the rule says here. Second theorem, it's on your formula sheet as well.
And then f of 3 is 2.
Right, f prime of 3 is 2, and then.
Okay, got it.
I have a question, because I wasn't here. It's about number 1, 2.
Okay.
Can you go over, can you just quickly go over A and B?
Mm-hmm.
It's like,
So f of 4 is just going to be my initial plus displacement. So that's the same thing that I did before. F prime of 7 is just the ordered pair, because that's f prime. And f double prime of 7 is just the slope, so that's just going to be -2.
Got it.
Okay. And then for B, we just had to gather information from this derivative graph. So we want increasing and concave up. So we have to create a slope sine line. So we just pick off all the critical points and then peaks and valleys as concavity. And then we just want to pair up wherever we see up arrow and concave up. All right, see you guys in class.
Thank you.
Thank you.
you.